All right then, let me first preface this talk with the reason why I decided to give this talk. I am Chief Evangelist at the Cloud Foundry Foundation, and what that means is I get to sit at the heart of an open source community and observe a lot of the things that go on within the community. Now, it might be very fresh in your memory that the log4j shell vulnerability was reported back in December 2021. So at that time, a lot of people were affected by the vulnerability, and the Cloud Foundry project was no exception. Now, there were many different parts of many different projects that were affected by this vulnerability, and what happened as a result was, as each hour passed, which felt like a year, as each hour passed, a lot of the different working groups were starting to report different vulnerabilities because of the use of log4j shell within each of these components. And I was bang in the middle of all of the communication that was going on, and I was constantly being made aware of the fact that some project or the other was now coming up in the radar afresh about using log4j within the project and having these problems. So what I would have liked, or what I would have liked to know, was what are the different projects that are in the ecosystem and what dependencies exactly they're each making use of. And so that really gave rise to why I wanted to give this talk, and the main part of the talk itself, which is about using what are known as SBoMs. Now, once you take a look at what these are, then you'll probably get a nice idea of why this is useful, and you might find different use cases depending on what you do as an engineer and how you work with containers and things like that. So software bill of materials, which is what SBoM stands for, is basically a set of, or a list of artifacts that are defined. Now there's a rather massive definition that you can read later, but basically what this says is it's a list of all of the different artifacts or dependencies or the other things that go into your particular software artifact. So the idea for software bill of materials originated in the realm of supply chain security. So as you're probably well aware, the supply chain industry has a notion of different suppliers who each contribute different components, and then these components coalesce into a larger product or a project, and then that product or project is what gets shipped downstream. So any sort of software or any sort of artifact which has an upstream, downstream sort of dynamic will benefit from using bill of materials. Now, in many verticals where there is like a chain of dependence on various things downstream, in order to create something of value upstream, downstream, there's always a need for a software bill of materials. Now this takes many different cues from many places, but one of my favorite examples is talking about a car. So a car is a composite of so many different parts. So obviously, we know the big ones, like it needs an engine, it needs tires, it needs a chassis, and things like that. But it can actually be broken down further into more modular components. And the automotive industry is actually very big on using bill of materials in order to build a final component machine, right? Much in the same way, there is a need for a software bill of materials in our industry. Now, the need for this is obviously very high as of today, and it sort of started with this executive order that was passed by the Biden administration a few years ago. And in this order, they specifically highlight the need for supply chain security in order to make more resilient software and in order for software to be more compliant and regulated just within the framework of the government. Now, there's also a very similar thing known as the CRA passed by the EU, in which they also take cognizance of making software artifacts that are very secure and very important. Now, in India and Sri Lanka, they're just watching Asia Cup. Okay, so we have no regulation for software or software bill of materials at the moment. But I think that also speaks of an opportunity where there's probably something that this community can come together and do in order to make people aware and in order to start exploring how this matters and start communicating this to the larger community around you. So, two things that we ought to keep in mind as we start to think about security, especially in this realm of using containers to deploy artifacts. You're all using containers. Anybody not using containers here? Please be aware you're in the wrong conference. So I assume that everybody here is using containers. And one of the things that I found really astounding about the use of containers is I have never met people who can say definitively that they know exactly what they're running inside a container. Is there anybody in the audience who knows exactly what's in their container that they built? Because I'd love to meet you and give you some special swag or whatever. But the point is, inside a container, and I'm taking this example of making use of a Docker file in order to build a container. Okay, so inside a container, what we usually find is that whatever commands that we supply from within a Docker file get applied as what is known as layers within the container. Now, God forbid these layers are not something that you can easily understand or read. You have something like SHA followed by a long key, and nobody who's ever built a container knows exactly what is what and what gets built and what gets moved and what happens. So containers by themselves are very complex, and we've not made it easy for people to understand or realize what's actually running within these containers, or what's the mapping between what they're trying to build and what are the different layers that are inside the container. So this is an example of all of the different dependencies that are in a Node.js container that one of my friends actually built. Now, any Node.js users here? Yes, no, maybe? Everybody's? Yeah. Thanks to the one gentleman who managed to raise his hand. So I'm not against Node.js or anything like that, but if you look at this beautiful looking graph, inside this Node.js container are LibreOffice. People have heard of LibreOffice? Yes, no, maybe? Am I audible? You're not audible. So anyhow, LibreOffice has nothing to do with Node.js. Now I need to know, why is there a LibreOffice that is a part of the Node.js container? Like that, you can probably pick out like 15 other packages or dependencies here very easily if you can read it, right? But the point that I'm trying to make is we've made it this complicated. Right? So there are ways in which you can skim this down. You can use undistros or distroless images. You can use tiny build images and tinier run images. There's so many things you can do. But a majority of us are not doing this, unfortunately. And that gives rise to this other thing that I wanted to highlight before getting into the solution space, which is the notion of software supply chain security. So the example that I gave from a few minutes ago, which is the Log4j shell example, which really rippled across so many different projects, and also I maybe affected some of the commercial vendors who around the Cloud Foundry project. So this can happen to you. Now, if you don't believe me, I'm sure a lot of you are using open source tools here. Yes, no, maybe? Can I get a yes or a no? Great. Again, if you're not in the business of using open source tools, maybe you're in the wrong conference. But I'm sure a lot of you make use of open source tools. And I'll give you another story. This might be true, this might not be true. There's somebody in your office, somebody got stuck with a problem. They didn't know what to do. The Docker file that they wrote isn't exactly containerizing the application in the desired manner. So what they managed to do is they scourge the internet, they read here and there, and then they find this Stack Overflow answer that says, insert these 4 or 5 lines in your Docker file and it'll get working. And then somebody below said, oh, it works for me. And you just decided to copy it, paste it in your Docker file, and start working. People have done this. You don't have to raise your hand. Your manager might be watching, so I don't want to get you in trouble. But the point is, I'm sure that this is not a workflow that's alien or foreign to a lot of the people who are here. But that has given rise to another problem. There are so many repos out there that are unverified, that are running malicious content within, that will have almost the exact same name as a repo that you're actually looking for, and then you might just include it as part of your Docker file and start running it without awareness of what exactly is going inside your container. I'm not saying this has happened to you. I don't want to put you in a paranoid panic mode either, but if you're putting unverified statements from Stack Overflow inside your Docker file, maybe it's time to stop. Okay? So the point is, there are so many problems out there in the world that can happen from insecure or unsecure development practices. And so we really need to ask ourselves, where do we start in terms of container security and in terms of improving security in general? Now, there's tons and tons of things that you can do in order to make your general development secure, but also specifically address issues that arise because of bad practices as you containerize your applications. And so one of the areas that I want to highlight is the work that the OpenSSF is doing. The OpenSSF is an independent non-profit foundation. It is a part of the Linux Foundation, and they have a whole raft of projects and a whole raft of resources that they've dedicated to making software development more secure. The OpenSSF is providing a lot of tools, a lot of services. They provide infrastructure. They even have this program called Alpha Omega, where if you have an open source code base, they will audit it for you for free, and they'll help by exposing the most threatening vulnerabilities that might exist as part of any open source code base. The OpenSSF envisions a future where all of the open development, the whole open source ecosystem, is able to deliver high quality software that is secure, and all of the security issues that are coming out of it are handled proactively. In the same vein, I would like to focus of these 10 different things that the OpenSSF advocates, I'd like to focus on one today. I'll save the rest for next year's KCD Sri Lanka, if you choose to invite me. But we'll focus on SBoMs, and we'll focus on SBoMs through a CNCF project known as Cloud Native Build Packs. Now, have folks here heard of build packs? Yes, no, maybe? Okay, I see a few tired nods. I know it's a long day for all of us, but Cloud Native Build Packs originated from this technology known as build packs. Now, about 10 years ago, which is like 100 years in the world of software development, there is this company called Heroku, which first came about. Heroku was the first company to actually do automation, and they did it extremely well. For a while, everybody wanted a piece of Heroku or a Heroku-like experience for their developers and for their deployments in general. Now, along the way, there was an open source, quote-unquote, clone of Heroku that was called Cloud Foundry, and it was developed by a company known as Pivotal. Now, Heroku and Cloud Foundry went their own ways in terms of how they approached application design and platform design, and both of them were very big in the platform as a service space, and they were both very successful in their own realms. Now, Heroku was a public cloud that offered a PaaS, and then Cloud Foundry was meant for private distributions, and it was open source, and so you could install it on your private cloud and make do with it, etc., etc. And now, for almost 10 years after they both operated independently, the communities at Heroku and Cloud Foundry have now come together and created what are known as the cloud native build packs. Now, cloud native build packs, as the name suggests, are designed to run on Kubernetes. Cloud native build packs is at buildpacks.io. If you want the website, I'm wearing a buildpacks.io t-shirt if you want to come and speak to me later. But build packs are now available in a cloud native flavor where a bunch of scripts are designed to export an OCI compatible image. So what that means is if you have a Docker-based workflow right now, you can use that same Docker-based workflow without any changes to make use of the containers that are built using cloud-native build packs. Now, there's so many different features about build packs that I don't want to get into the details of, but they're very much more modular than Docker files, than Docker-based containers, and they eliminate the need for Docker files. And so these are like the big things that I like about build packs. So you don't have to necessarily create a workflow where you're maintaining a lot of Docker files and you're supplying Docker files for your teams and things like that, because I think Docker files are not easy to write. I mean, like, obviously there are the easy ones, and then like I mentioned, there are the Stack Overflow borrowed ones, and now there are ChatGPT written Docker files and things like that. So why do you want to write fake Docker files when you can eliminate them altogether? That's like my big pitch if you want to try build packs. All right. Now, build packs are being, positioned as a better way to containerize. They integrate with Tekton, with Circle CI, with GitHub Actions, and whatever it is that you might be using for CI/CD. So it's pretty convenient to start using them. And there's another project called Paketo build packs, which are basically an implementation of the build pack specification. Now, in the demo today, I'm going to showcase Paketo and what it can do and things like that. But there's build packs that are actively developed and distributed by the folks at Google, by the folks at Heroku, and by the Paketo open source community. And the reason I'm highlighting the Paketo ones is, A, they're open source, and B, they belong to the Cloud Foundry Foundation. And it's sort of my solemn duty to continue to promote them. So again, Paketo, largely share the same main features and benefits of build packs themselves. And there's a different and distinct build pack available for every language or framework. And also for other technologies, like if you want to, let's say, integrate New Relic observability into your application, there's a New Relic build pack for that. So if you want to do Nginx on your application, there is an Nginx build pack for that. So again, I'm not going to get into the details of how build packs work and how they function and things like that. But we want to understand a little bit about how does it solve the two problems that we actually mentioned. How does it solve the problem of helping people understand what is inside a container, and how does it solve the problem of there being a lack of security within the software supply chain? And that's really what I want to focus on for the rest of this talk. When using build packs, the fundamental way of invoking it is by using the pack CLI. So pack is a CLI built and distributed by the build packs community itself. And pack can help you. Whoa. Well, technical conferences are no fun if there's no AV issues. Um, yeah, I think it's restarting. I don't know why. That's okay. Um, just bear with me a couple of minutes. The computer decided to restart. Don't ask me why, but it just decided to. Anyhow, what I was saying is there is pack build, which is the command that is used in order to build the container itself. And pack build goes in a few stages. So the first stage pack build will do is it will analyze the source code and it will detect the languages that are used. So if you have a Node.js app, let's say, you can build it just by saying pack build. If you have a PHP app, you can build it just by saying pack build. If you have a Golang application, you can build it just by saying pack build, right? So it provides this one command interface by which it provides this one command interface by which applications get built and get built into a container that is available for use. Okay, we're back on. So you can stop checking your score. I am very inclined to try a build, but I don't know if it will not work. I don't mind looking like a panda, but let's see. Okay, so I have a simple Go app here, and I'm going to say pack build KCD Sri Lanka. And what this will do is demonstrate that tiny life cycle that I was talking about. Now it will hopefully not download the whole internet, but it will go through these stages or phases that I was talking about. The first one is it will detect what the language is that we are trying to build an app out of, and it will select the corresponding build packs. Now it can do this for every language family basically, like I was highlighting. This Go installation process will probably take a few minutes, but while it goes through that, the build process itself has space for accommodating SBoMs to be generated as it goes through the build. And that's the part that I want to highlight during the build process. So as this goes through, like I mentioned, the first part is the detection. In the next phase, it does the actual build itself. And finally, it will do an export where it will export the whole app as a container. Now, while this is going on, let me showcase this example container that I created and uploaded this morning, just as a backup. So this is my Docker Hub repo, and this was built this morning from the comfort of my hotel room. But this was, again, built using Pack. And what I'll do is I will make use of Dive. Have folks here heard of Dive? Yes, no, maybe? So Dive is a cool tool that will help you look at what's inside a container image. So again, it's not very sophisticated or not very much more human readable, but it will give us an idea of what's actually in here. Now, the layers of the container are here, and now as I go through these layers, hello, we have something here. Um, and I wanted to highlight that SBoMs are available automatically. So there is no separate work that you need to get your app developers or your engineers to do in order to generate these SBoMs. They are built into or automated into the pack CLI build process itself, which is huge because compare it with your current workflow of using Docker files and inserting all of these SBOM generation commands within, etc., etc. So this other image has also completed building. So like I said, it's yeah, it's gone again. But anyhow, the important thing that I wanted to highlight was the fact that the SBoMs get generated automatically, and you can actually view them as plain text files wherever you want to. Now, there are 3 competing standards for SBoMs. There's one called SIFT, there's one called Cyclone DX, and there's one called SPDX. So the SPDX is the one that is pushed by the OpenSSF and the Linux Foundation in general. Like every nice thing in the world, there's competing standards for SBoMs. And so you can make use of whichever format you want, depending on what your use case is. Now, I'll quickly show what each of these formats look like. So when using pack, you can, I'll fix that. Yeah, so you can see there are these 3 different formats in which SBoMs have been generated, and all of those have the different Go modules that are actually being made use of to build that container. So this is a much more convenient way of learning what's inside your container than having to go through layers or reading Docker files or things like that. This is the exact same information, is just in a different format. So this is the SPDX format, and that was the Cyclone DX format. Now, both of them have their own merits, both of them have their demerits. Let's probably not get into that yet. But the idea is there's competing formats that are available that are both good and useful and can get the job done. And pack, the CLI, can actually allow you to download the SBoM. So you can do pack SBoM download, specify a folder. Oh, of course. So the name of the container and so if you navigate to that folder, you can see SBoMs generated for that container that we built. Bill of materials is getting a lot of traction in a lot of other places. Kubernetes has also started a project now called KBOM, or Kubernetes Bill of Materials. It will let you know exactly what's inside your cluster and how you can make use of it, things like that. Again, thank you for having me. Thank you for your patience on a day Sri Lanka is playing a cricket match. And apologies for the technical glitches. I will obviously post all of this information. You can find me on whatever social media channels. I'm Ram Iyengar at most places. But yeah, if you have any questions, again, I'm the guy with the Build Packs t-shirt, and I'll be hanging around. Thank you so much.